Today's lab, we are going to make an ester. We're going to carry out the Fischer esterification, and to do that, we're going to use a carboxylic acid. We've got para-amino benzoic acid, and then we're going to use ethanol as our nucleophile. This reaction is equilibrium based. We're going to heat it for it to go at a reasonable rate. And then notice we're also using sulfuric acid. The sulfuric acid is going to serve as our catalyst. The end product that we're going to make is an ester. We've got the C-double bond O-C linkage, and we're making ethyl para-amino benzoate as our product, i.e. known as benzocaine, which is, I think most everyone knows, is a topical anesthetic. We release water in the process. I want to kind of show lasso chemistry first, and then and this isn't all the individual steps, but enough to get us through it. Lasso chemistry, we're going to split out water between the carboxylic acid and the alcohol. So if you kind of envision, we're going to take the OH off the carboxylic acid and the H off the alcohol. So if we remove water, HOH, we're going to take the OH off the carboxyl group and the H off the alcohol, and then whatever's left we join together to get the ester. Now, this is considered a derivative of carboxylic acids. When we make these, there's different derivatives you could use actually to make the ester. The carboxylic acid is the weakest in terms of the reactivity. And to kind of give you an idea of what happens in the process, these reactions are referred to as nucleophilic acyl substitutions. And if you kind of compare what we started with the benzoic acid derivative here, we're taking the OH group and substituting that with an O-ethyl group, whatever the alkyl group that was attached to the oxygen of our alcohol. So in the process, what happens, nucleophilic acyl substitutions are different than nucleophilic additions. They're really a combination of a nucleophilic addition followed by elimination. So before we've taken a look at benzoic acid derivatives and their reactions, if we had a nucleophile, we would see the nucleophile attack the carbonyl group, pi bond breaks, O becomes O minus, eventually picks up a hydrogen to form some type of alcohol. What happens in these nucleophilic acyl substitutions, we first have an addition, but initially before we have that, we have to protonate the carbonyl oxygen, and that's the reason we're using the sulfuric acid. If we protonate that makes this carbon of that original carbonyl group more sensitive to nucleophilic attack. So the nucleophile will come in, attack that carbon, pi bond breaks, those electrons go back up on the oxygen. So this is where the nucleophile will come in, attack the carbonyl carbon, pi bond breaks, the positive charge is removed. We've got acid, and I'm just showing this OH, it could have very well been that one. This can get protonated again, and then notice what happens. If this is protonated, that turns into a good leaving group. Electrons come back in to reform that carbonyl bond, and then kicks off the water. We have this intermediate. The last step is really an acid-base reaction. We've got water present that can certainly pick up that hydrogen to regenerate our acid catalyst. So notice it starts out in addition to the acid-base reaction, but once the nucleophile adds, it doesn't stop there. Then we have elimination to form, in this case, our ester. This reaction is at equilibrium, which means we're never going to get 100% conversion of our benzoic acid derivative to the left. So there's a couple things. We're heating it, obviously. If you add more of a reagent than you need, then certainly that can help push that equilibrium to the right. We're using an excess of the ethanol. That's actually going to serve as a solvent and also as our nucleophile. So by adding an excess of the ethanol, we can push that equilibrium further to the right, but we will never have 100% conversion to the ester. Equipment needed for today's lab, the formation of benzocaine. We're going to carry out the reaction under reflux. We're going to use a 25 milliliter round bottom flask. Of course, we need a stir bar. We've got our condenser, tubing for the condenser. obviously clamps. We're going to use a heating mantle today in order to carry out this reaction. Today's lab, we're doing the preparation of benzocaine, and what I have in the round bottom flask, this 25 milliliter round bottom flask, is 1.019 grams of para-amino benzoic acid, and to that I've added 10 mils of ethanol. I'm letting this stir with no heat, just letting it stir until all of the para-amino benzoic acid is dissolved. Once that has dissolved, then I'm going to add a milliliter of concentrated sulfuric acid, and then we'll begin the reaction of the reflux. I'm going to go ahead and add the 1 milliliter of the concentrated sulfuric acid. And if you notice, there is some precipitate that formed, and that is normal. As soon as we apply the heat, which I'm going to do in just a second, then that solid should dissolve. What I'm going to do is hook it up to the reflux column. As soon as I get that, we'll come back, take a look, and then we'll start heating the mixture. I went ahead and set up the apparatus for reflux condensing. We've got the acid in there, as we saw earlier. We've got this white precipitate that formed. I've got water going in the bottom, out the top. Also, anytime, even though if it's not mentioned in an experiment, anytime you're using these ground glass joints, please take the time to grease those. I went ahead also and changed my gloves after the addition of sulfuric acid, just a little safety precaution there. I've turned the variac on. We're using the heating mantle as our heating source with the variac. And I'm going to monitor. As soon as it starts refluxing, we'll come back and take a look at what it looks like. Well, once it starts refluxing, we'll count 30 minutes. If all the solid has dissolved at that point, we'll go further to collect the product, the benzocaine. If there's still solid left, we'll need to add another small amount of ethanol and a little bit more of the acid catalyst, the sulfuric acid, and heat for another 30 minutes. We won't know until after the first 30-minute period ends. It's been 30 minutes since we were heating this under reflux, and as you can see, all the solid has dissolved. So I've turned the heat off. We're going to let this cool to room temperature, and then we'll follow the next step of the procedure.